Hey crew, it's SAT Hijackers back at it again, hijacking the SAT one problem at a time. Geometry can be weird, but it doesn't have to be painful. In this video, I'm walking through real SAT geometry problems and showing you how to break them down step by step. Whether you're feeling confident or completely confused, you leave this video knowing more than you came with. Let's figure it out together. So here we have a triangle problem. The question states, in triangle XYZ, angle Y is a right angle. Point P lies on XZ and point Q lies on YZ, such that PQ is parallel to XY. If the measure of angle XYZ is 63 degrees, what is the measuring degrees of angle XPQ? So now we're going to draw a triangle and we're going to label it as well. So we have our XYZ. So we have our 90-degree angle at Y. So now we know that we have a parallel line with point P lies on XZ, so we're going to create a point right there. And it runs in a parallel line, so we're going to create a parallel line and other point that intersects YZ. So we have a parallel line from XY to PQ. So now we're going to label P and Q on lines XZ and YZ, P and Q. So now we need to put in our degrees that was given to us. So we know that XYZ is 63 degrees. And we know since this parallel line cuts into YZ, it creates a 90 degree angle. So with our 90-degree angle drawn, we have a triangle. We have two triangles. So now we're going to have to find our missing angle at QPZ. So the inside of a triangle is equal to 180 degrees. So we're going to have 180 degrees is equal to X, which is going to be our angle QPZ, plus 90 degrees, plus 63 degrees. Now we're going to simplify this equation. So we're going to have 180 degrees is equal to X plus 153. So X plus 153. Subtract 153 from both sides. Minus 153. So we have X is equal to 27. So we know our angle QPZ is equal to 27 degrees. So here we can see that line XZ is a straight line, and that we have line PQ that cuts into our straight line. So we know that this angle has to equal to 180 degrees. So Y plus X must equal 180 degrees. So we subtract 27 from both sides from 180. So you have 180 minus 27 is equal to 153 degrees, which makes our answer for Y 153 degrees. So angle XPQ is equal to 153 degrees. So here we have another triangle problem. The question states, in triangle XYZ, angle Z is a right angle, and the length of YZ is 24 units. If tan X equals 12 over 35, what is the perimeter in units of triangle XYZ? So I'm going to draw a triangle and label it. So since we have tan X in our question, we know that we have to use trigonometry, and we always want to draw a magical abbreviation for trigonometry, which is SOHCAHTOA. So I'm going to draw SOHCAHTOA out for you guys. Now that I've drawn our SOHCAHTOA, we want to identify our abbreviation for tan. So our abbreviation for tan is TOA. So that represents tan is equal to opposite over adjacent. So I'm going to show you guys our opposite and adjacent sides. So we have tan X. So ZY is going to be our opposite side as it's directly across from my angle X. So 24, pardon me. 24 is going to be our opposite side. So 24 is opposite. And XZ is going to be adjacent side because it's directly touching our angle and is not the hypotenuse. So I'm going to draw out our tan as we're going to draw our tan ratio, which is 12 over 35. And then we're going to have our adjacent side as XZ. So we're going to equal this. We're going to equal this 12 over 35 to 24 over our adjacent side because those are going to be congruent because they follow the same ratio. So we're going to have 24 over XZ. Now we need to cross multiply. So 12 times XZ and 24 times 35. So you're going to have 12XZ is equal to 840. Now we're going to divide by 12 to create a two-step equation. So divide 12 on both sides. So xz is equal to 70. Xz is equal to 70. And that's how we find our adjacent side. However, we're not done yet. The question asks for the perimeter of triangle XYZ. So now we're going to need to find side XY. So we know that XZ is 70, ZY is 24. So we're going to have to use Pythagorean theorem because we want to find the hypotenuse. And we know that whenever we want to find the hypotenuse, we use the Pythagorean theorem. So A squared plus B squared equals C squared. So now we're going to input our numbers in our variables. So we have 70 squared plus 24 squared is equal to C squared. So now 70 squared is 4,900 plus 24 squared, which is 576. 576 is equal to C squared. Equal to C squared. So we simplify the left side of our equation. We get 5,476. 5,476 is equal to C squared. Simplify this two-step equation by square rooting both sides to get rid of our square root on the right side. So C is equal to 74. So now we know that our hypotenuse is 74. We have all three sides. So now we need to find our perimeter. So the equation for our perimeter is side 1 plus side 2 plus side 3. So now we're going to input our side. So we have P is equal to side 1. We're going to have as 74. Side 2, we're going to have as 24. And side 3, we're going to have as 70. And once we add all of these together, we get P is equal to 168. So P is equal to 168. Therefore, our answer is B. Very simple question. You just have to understand your trig ratios and how to convert the proportions. So here we have a circle problem. It says in the xy plane, the graph of the given equation is a circle. What is the length of the circle's radius? So I'm going to draw the equation that was given to us. So we have x squared plus 14x plus y squared is equal to 8y plus, 6y plus 109. So we're going to subtract 6y from both sides because we want to make this a quadratic equation. We want to make this the equation of a circle. So we're going to have x squared plus 14x plus y squared minus 6y is equal to 109. So now we want to make our x and y's are almost in the form of a quadratic equation. So we're going to want to complete the square for both of these equations to make x squared plus 14x into a quadratic equation. So we're going to do 14 divided by 2 squared equals 49. Then we're going to do 6 divided by 2 squared is equal to 9. And we just completed the square for both of these equations so we can make both of them a quadratic equation. So after this, we can now factor this equation. So now we can do x squared plus 14x, x squared plus 14x plus 49 plus y squared plus y squared minus 6y plus 9 is equal to 109. So now we want to solve our quadratic equations because we completed the square. These solved equations are going to be a perfect square root. So we're going to have x plus 7 squared. It's going to be a perfect square, pardon me, not perfect square, perfect square. We're going to have x plus 7 squared plus y minus 3 squared. And because we added 49 and 9 to one side, which is our left side, we're going to have to add this to our right side. So we're going to have 109 plus 49 plus 9. So now I'm going to have to simplify the right side of our equation. So we're going to have x plus 7 squared back again plus y minus 3 squared equals 157. Pardon me, 167. So because the equation of our circle is equal to r squared, the number that we equal is equal to r squared. We have to square root our number that's what we're equal to, which is 167. So we're going to have square root c is equal to r. Because that number, 167 is c squared. So we're going to have to square root it to get r. So we're going to have square root 167 is equal to r. Therefore, our answer is C.